Arctic cyclones could be the missing link in sea ice depletion models. We're talking about the North Pole. A new study from University of Oklahoma gives possible insight into the under prediction of sea ice depletion and the formation of Arctic cyclones. This is according to the University of Oklahoma research. Arctic sea ice extent for September 19, 2023 was 4.23 million square kilometers. That's 1.63 million square miles. It was the sixth smallest summer minimum on record. The orange line shows 1981 to 2010 average extent for that day. A NOAA Climate.gov image based on data from National Snow and Ice Data Center. Led by Stephen Cavallo, professor in the School of Meteorology in University of Oklahoma, the study could lead to more accurate weather and climate models and better forecasting of Arctic cyclones. Since 1979, Arctic sea ice extent, a term that describes the area of the Arctic Ocean covered by the ice, has been reduced by 40% in the late summer months. Global climate models have consistently underpredicted that reduction. The study examines what Cavallo and his co-authors call very rapid sea ice loss events, or VRILs for short. The sea ice declined since 1979 in the sum of numerous VRILs that individually occur in periods of 5 to 18 days. Cavallo's publication suggests that Arctic cyclones are at least partially to blame. Arctic cyclones are weather phenomena that are tricky to predict and even trickier to incorporate into models. Though the exact mechanisms of why these cyclones may accelerate the ice loss are not fully understood, Cavallo suggests two theories. The first is the interaction of turbulent seas with ice. If the winds get strong and the ice is thin enough, the cyclones can create waves that break the larger ice floes. Breaking them up into smaller ice floes accelerates the melting, and it can happen at a really fast time scale, he said. And the second theory is that upwelling, the mixture of warmer water below the sea surface with cooler water at the surface, increases temperatures that help melt the younger, thinner ice from below in a short amount of time. Observations of these events and their effects are difficult. Ships avoid forecasted storms, and a plane could not fly into the Arctic cyclone close enough to the ocean surface to collect data on upwelling or wave ice interactions. Cavallo says they've discovered that cyclones have to be in the right place to make such a drastic difference to the sea ice extent, needing to occur over an area of thin ice that is usually no more than a year old. And this research also suggests the connection between Arctic cyclones and tropopause polar vortices, or circulation in the upper troposphere over the polar regions. And Cavallo said tropopause polar vortices are sometimes present for months before an Arctic cyclone forms, while Arctic cyclones are usually only predicted several days in advance. Because the vortices are present so far ahead of a cyclone, they could lead to better forecasts of cyclones, and this would benefit residents in areas such as Alaska, northern Canada, and Greenland, and aid in shipping industry, which has made increased use of the Arctic as ice continues to recede. And now that we think these processes are occurring, the question is, how do we get that information into the models so that we can get better predictions, said Cavallo. It's a hard task. Cavallo said that the broader scientific community is still unsure whether the Arctic will become ice-free, but that looming lack of ice could significantly impact large-scale atmospheric dynamics throughout the northern hemisphere. And we're still trying to figure out exactly how sea ice changes. These changes will affect any of the extreme weather that is happening right now. And this is from University of Oklahoma, on Message to Eagle. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.